Hey everybody, it's Mr. N here, and we've got our next lesson. This is on transformations of functions. And basically, this is review. Most of you guys have covered this starting in Algebra 1 nowadays, and then continuing with Algebra 2. But here's the basics of it. For translations, basically, we're shifting it up, down, left to right. If we have a function, f of x, and we add something to it, it's going to shift it up. If we subtract, it's going to shift it down. Now, if we do something to the inside of the parentheses with the x, then it shifts it left and right. And it's opposite of what you think. So if it's a minus, it's going to shift it to the right. If it's a plus, it's going to shift it to the left. And then over here, if we have a constant out in front of our function, this will stretch the function. And we're going to do examples of these in class. And if we have 1 over c, this actually compresses it vertically by a factor of c. If I put the c on the, think of it like this, right here, c, if I'm multiplying it, it's going to make this y value, right, whatever f of x is when I get the answer and I multiply by something, it's going to make the y value bigger. So it's going to make it higher or lower. So it's going to vertically stretch it. And same thing here. If it's a fraction, it's going to compress it. And then the opposite of what we would think. If I put it on the inside and multiply the x by it, this affects it horizontally now, but if I multiply, it compresses horizontally. If I divide, it's going to stretch it horizontally by that factor of c. And then this one you guys are familiar with. If I put the negative out in front, it's going to reflect it about the x-axis. And if I put the negative on the inside, it's going to reflect it about the y-axis. Then we've got combinations of functions. For example, over here, these are composites on some of them. If I have, let's undo that and use this tool. If I have f plus g, I'm adding two functions, subtracting two functions, multiplying, and dividing over here, assuming that the g function is not 0. If I have f plus g of x, you can say that this is the f of x plus the g of x. It's the same thing. And if the domain of f is a and the domain of g is b, then f plus g would be the intersection, the ones they have in common. And then we've got the compositions, f of g, I can write it as f of g of x and f of g of x in this manner. Okay, let's just do a couple examples here and then we will move on. So for these ones right here, it says if f of x equals x squared, g of x equals 2x plus minus 1, find f of g. So f of g, here's my g, and this is like saying f of g of x, right? Same thing. So the g is inside the f. So this becomes 2x plus 1 squared. On this one, it's the other way around. I'm putting the f inside the g, so it's 2 times the x squared plus the 1, so 2x squared plus 1 on that one. Okay, let's take a look at a couple of these stretching and compressing. It says, sketch the graph of f of x equals the absolute value of x. Change the equation to reflect a shift of f 4 units up, b 5 units down 5 units, c reflect about the y, and d stretch by a factor of 2. So sketching this graph real quick, I will do it on the side over here, and it's an absolute value function, so it will look like a V like this. So for part A, if I shift it 4 units up, my new equation, f of x, will be the absolute value of x plus the 4. And since it's going up and down, that's on the outside. For part B, if I'm going to do down, that'll be f of x equals absolute value of x minus 5. For part C, if I want to reflect about the y-axis, I would need to put the negative on the inside. But if you take a look at this one, it doesn't matter. If I reflect this about the y-axis, here's the y-axis, and I rotate it basically this way, flip it, it's going to end up looking like the same thing. It's not going to matter. And then part D over here, we've got to stretch it vertically by a factor of 2. And to stretch vertically, I'm putting a c out in front of that, and since it's a factor of 2, it'll be the absolute value of 2, or 2 absolute value of x. Okay, this example right here, I'm going to do when I see you guys in class. In addition, we've got some more over here where we describe these transformations and and I want to save these to do with you guys in class. So we will go ahead and we'll stop this basic lesson there. I'm also going to give you a nice little worksheet to help you with your transformations that kind of breaks things down. And you can find it on the website when you go under additional math review and click on transformations of functions. You'll see it there, but I will post it also up for you guys so that you can have that as well. So make sure you have that ready to go when we meet in class. All right, so this was a quick one. Thanks for watching. Hit that like and subscribe button, and I will see you guys in the next video.